Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about one more application of dynamic programming, that is longest subsequence problem. But before we start, a small information I'd like to share. In this channel, we produce every video in two different languages. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. Let us see the objective of the problem. What we are going to do by this? We are given with two sequences of characters. You can say two strings, and we are going to find the length of the largest subsequence present in both of them. And the subsequence is a sequence that appeared in the same relative order, but not necessarily that continuously. Let us see what is the meaning of that. Let us say we are having a sequence or a string 1 B Q D R C V E X Y Z, and another sequence we are having A B C V D E X Y Z. Now we want to find the longest sequence which is common in both of this. So we are taking the first alphabet B and we are going to compare with the second sequence. So we are comparing with A, then B, these two matched. Similarly, the next character we are going to take, Q. Again, we are going to start with the first character A of the second string. So A, B, C, V, E, X, Y, Z. It means none of the character matches with Q. So Q is not a common alphabet in sequence 1 and sequence 2. And if we'll go in the same manner, we'll get B, D, E, X, Y, Z is a subsequence which is common in string 1 and string 2. Now you can see the order in which B, D, E, X, Y, Z appeared in string 1 and string 2 are same. The length of the subsequence is 6. But is it the largest subsequence? Now if we'll take one more sequence, that is B, C, V, X, Y, Z. It is having length 7. It is a subsequence. The order in which these alphabets appear in both the statements are same, but this sequence is having more length than the other one. So this is what we are going to find. So we are going to apply this algorithm in order to find the longest subsequence. So we'll be able to understand this with the help of an example. Now let us take, we are having a string 1 that is called largest, another string we are taking that is adjunct. So what we are going to do is, we are going to take a matrix in which the columns I'll write string 1 that is largest, and in row wise I'll write the alphabets of string 2 that is adjunct. And apart from that, initially I'll write the empty string for string 1 and string 2. And what I am going to do, I am going to write the first row and first column to be zeros. What is the meaning of that? If either first string is empty or second string is empty, in either case the subsequence will be empty. So what we are going to do, we are going to write zeros here. The next thing is, we are going to match the first alphabet of string 2 with the first alphabet of string 1. Here A and L. Look at this particular algorithm. What we are going to do, when these two will be matching, we are doing this thing. And if we are not matching, we are going to take the maximum of these two data. That is Li-1j and Lij-1. So maximum of these two is 0. We have written here 0. Now the next alphabet I'll take is string 1, next character, that is A. What I am going to do, if these two are same, Li-1 and J-1, whatever be the value, I'll add 1 to it. Li-1, Ji-1 is 0. To that I'll add 1 and write it here when both of the alphabet matches. So it becomes 1. Now A and R, they didn't match. If they are not matching, I am taking the maximum of these two. I am writing here. This diagonal arrows, where I am incrementing it by 1, I'll keep a mark of it. Okay, and this type of symbols I'm going to eliminate every time. Now the maximum of these two is 1 because A and R, they are not matching. The next symbol is A and G. They are not matching. That's why I'm going to take the maximum of these two and I'm having 1 here. The next alphabet is A and E. The maximum of 1 and 0, I'm going to write here 1. Next alphabet is A and S. They are not matching. That's why the maximum of these two, 1 I am writing here. Then A and T, the maximum is 1 and I am going to write 1 here. So the first alphabet of string 2 is matched with all the alphabets of string 1. Now let us take the second alphabet of string 2. G compared with L. Both of them are not same. I am going to take maximum and write here 0. The next one is G and A. They are not matching. Going to take maximum and write 1 here. Next G and R. They are not matching. Going to write 1 here. Next G and G. They are matching. So that's why I am going to write the diagonal here and adding the diagonal value by 1. So my value will be 2 here. The next is G and E. They are not matching. So I am going to take the maximum of these two and write it here. Then G and S. They are not matching. So I am going to write the maximum here. Then G and T. They are not matching. So I am going to write the maximum here. The next thing is, next alphabet of string 2 is E and first alphabet of string 1 is L. They are not matching. So I am going to take the maximum, write it here. Then E and A, they are not matching. That's why writing the maximum here. Then E and R, they are not matching. That's why writing the maximum of these two here. Then E and G, they are not matching. That's why writing the maximum here. The value becomes 2. Now E and E, they are matching. So to the diagonal element, I'll add 1 to it and write the value here. So the value becomes 3 here. Then E and S, they are not matching. That's why writing the maximum of these two elements, the value becomes 3. Now E and T, the maximum value is 3. I am writing it here. Now the next alphabet is N. I am going to check wherever it is matching in the string 1. Now N with L, they are not matching. So I am going to write the maximum of these two, that is 0. N and A, it is not matching. That's why writing the maximum of these two, value I am getting 1. Then N and R, they are not matching. The maximum is 1. N and G, they are not matching. The maximum is 2. Then N and E, they are not matching. Maximum is 3. N and S, they are not matching. So the maximum is 3. N and T, they are also not matching. So maximum is 3. Now the last alphabet I am having for string 2 is T. So T and L, not matching. So I am writing 0. T and A, not matching. Writing the maximum 1. Then T and R, they are not matching. Writing the value, the maximum 1. Then T and G, they are not matching. The maximum of these two is 2. Then T and E, they are not matching. The maximum value is 3. I'm writing here. Then T and S, they are not matching. The maximum value is 3. I'm writing it here. And T and T, they are matching. To the diagonal element, I'm adding here 1. So we have applied this algorithm till all the element of string 1 and string 2 completed. The next step is to find the subsequence. There are few steps that we need to take care. The first step is start with the cell Lij with the optimal length. The second step is write the character if an arrow pointing to the cell Lij. Then follow the tail of the arrow and take the cell for consideration. What consideration we are going to do? If the cell has a pointing arrow, write the character. Otherwise, compare the value of Li-1j and Lij-1 and go in the direction of greater value until we find a arrowhead or a starting cell 0, 0. Now you see here, the first thing that we are going to do here is we are going to find the optimal length. The optimal length is here 4. Now on this 4, is an arrow pointing to it? Yes. So we are going to write the value, that is T. Now we are going to follow the tail. And after the tail, we are going to see if at all any arrow is pointing to it or not. Now these three appeared because we are adding 1 to it or the comparison of between these two. So obviously we have not added 1 to it and got 3. So we are going to compare these two. So this value is 3, this value is 3. So any direction I can go. So let me go in this particular direction because both of them are same. What we need to do, you see, compare the value of Li minus 1j and Lij minus 1. I supposed to move in that particular direction. Because both of them are same, I have moved up. Now I am here. Now this value is 3. How this value appeared? Whether a arrow is pointing to it or I have taken the maximum and I have written. So obviously I am going to compare these two. Out of these two values, which one is having greater? So obviously I need to move in this particular direction and I found here 3. Now is there any arrowhead pointing to it? Yes. If arrowhead is pointing to it, I'll write the value. So E I am going to write. And I'll follow the tail. Now my point is here. Is there any arrowhead pointing to it? Yes. So the corresponding value is G. I am going to write G. Now again I'll follow the tail of it. So the value I'll get here is 1. Now this one I got because of the diagonal enhancement or by comparing the opposite diagonals. Obviously by comparing the opposite diagonals I got. So out of these two, in which direction we are going to go? We are going to go whichever value is maximum. So we are going to reach to this particular value. Now here, is there any arrowhead pointing? Yes. If arrowhead is pointing, I am going to write the value. Now follow the tail. Now we are here at 0, 0 cell. Now we will be stopping here and we got the longest subsequent is AGET. I hope you understood this. The complexity of this particular problem is big O of M and N. Here M is the length of the first string and N is the length of the second string. I hope you understood how we found the longest subsequence problem by using dynamic programming. If you understood, give me a like and share among your friends. In our next video, we are going to talk about yet another application of dynamic programming. See you then. Take care. Bye.